Sometimes you have a situation like this. You have a complex nested object which has many properties in there which are named the same. So for example, ID. And you need to keep track of what kind of types all these different IDs have. So what you could do, of course, is you could create a union type which contains all the possible types this ID property can have. Now the problem with this is that this is quite error prone. If you change something in your type and you forget to update your ID type, then these two types are no longer in sync. So let's fix that today. We will create a utility type which you can pass your type you want to check and the property names you want to figure out the types from, and this then automatically will create a union type for you with all the types your input property can have. Let's get started. So what is the use case for such a find utility type? Well, let's see an example here, and let's say we have a type here which is called person, and we have an ID in there which is of type string. Now we also have first name, last name in there, but there are also more nested types. So for example here file data and account. And when we check for file data and account here, we can see file data has an ID which is of type number, and account has an ID which is of type complex ID, and this complex ID itself has an ID which is of type date. So what happens if you want to do the following? Let's say we want to create a new type here, and let's call this type ID. Now let's say we want to create a union from all the possible types this ID can have. So we have to do this manually. We have to say we want to have it either to be a string or a date or a number and so on. Now the problem with this approach is if anything in these types here changes, so for example if this ID here now has another type, then we need to update this ID type we've created manually, and this can lead to some errors during runtime because we have forgotten to update this ID type here. And this is exactly one of the use cases we can use this find type we will now create. So let's first remove this here and let's create a new type here. And let's call this type find all types for key. Now, what do we need to pass in as a generic argument here? The first thing is a type which has some properties you want to check. So let's call this search in because we want to search in this type. And the second one will be the key to look for. Now this extends property key because we only want to allow valid property keys as a value in there. Now this property key, when we check what the type is, we can see it's either string, number or symbol. So this means that we are only allowed to pass in these types because otherwise this cannot be a valid property key because these have to be of these types. Now let's implement this. Now before we start to do this, let's think what we want to do. So we want to check if a type we pass in, for example this person here, has a property in there which has the same name as this key to look for. So we want to call into this person type and check each property if the name of this property is the same as this key to look for. But we also have to do this recursively because this file data also is an object itself, so we have to check in there again. So how can we achieve this? Well, let's start easy here. And the first thing what we will do is we will say search in extends object, because what this will do is it will check if this type we pass in is an object or not. If this is an object, we are interested in the properties. Otherwise, we are not interested at all. So what we now do is we say, okay, if this is the case, so if the search in is an object type, we then want to check if any of the properties of this object has the same name as our key to look for. So what we do is we say key to look for extends key of search in. So what is this key of search in? This creates a union of all the properties in our types. For example, ID, first name, last name, file data, and account. And what we then do is we just check if this key to look for is inside of this union. So if this is the case, then we want to store the value of this key. So we want to store the search in key to look for. So why do we want to do this? Because when this key to look for is inside this union, this means that the key to look for is a property of our type we pass in. So we want to store the type of the property. Now, otherwise we are not interested in it and we just return never. Now we have to do also an else case. So if this is non-object, we just return never because there is no way that, for example, a string here is the name of our property in this case. So let's see if this is working. We create a new type here, test, and we just say find all types for key, and we pass in our person and we pass in ID. Now let's see what the result here is. And we can see we get back only a string. Now this is okay for this case here where the ID is a string, but our file data, for example, has an ID of type number. So why isn't this working? Well, because we are not recursively calling into our type. We are only doing this for the most upper layer of our type, so only for ID, first name, last name, and so on. But we are not recursively calling into our file data or account. Now, how can we do this? We can easily extend our existing type, because what we do here is we are looking for the property names directly on this object, but we also want to do a recursive call. So we say, okay, we want to have the type here, and then we use a union, and now we can use a mapped type. Now what we do here is we also loop over all the properties of this search in object again, and we create a map type. We say p in key of search in, because what this will do is it will again loop over all the properties of this search in and save the property name in this p here. And what we then do is we just call our find all types for key again, and we use our search in p as a new input for our search in, and the second parameter, of course, we just use the key to look for because nothing really changed here. So let's backtrack a little bit and find out what we really are doing here. So here we get us the type of our key to look for if it's found anywhere in the person, for example, so in this search indirectly. But what we then also do is we go in there and we loop over all the properties, and we do exactly the same for all these inner properties. So what this means is this P here is either ID, first name, last name, file data, or account. So for each iteration, this will look differently. So during the first iteration, instead of this P, it will have ID in there. Then it will have in there first name, last name, and then it will also have in there file data. That's when it gets interesting, because when we pass in file data, then this check here, search in extends object, will be true. And it will then check again in this file data if there's any property with the name ID or the name of this key to look for we pass in. So by using this, we also recursively check our inner types for this ID property or for this property we are looking for. Now, when we look for this result here, this is not really what we were looking for, because we can see here this is just like a union of complex objects, and this is not really what we were looking for. Now, how can we fix this? We need to do a really cool trick, but this maybe looks a little bit crazy when you first see it, so we will do this step by step. So what we will do here is let's put this on new lines, and we will use an indexed access on our mapped type here. And then we will do a key of search in. And we can see here, now we get another result. So let's see what the result here is. We see we get string, number, complex ID, or date. So this now works fine, and it finds all the possible types our ID property has in our person type. But how did this work? What is this key of search in with this index access here? Now let me show you a simple example. So let's say we have a type here input, and this input has two properties, A, which is a string, and B, which is a number. Now when I create here an out type, we can say here out is equal to input, and of course this is exactly the same because nothing really changed here, we just created an alias. But what happens if I use here an index access and I say key of input? We can see here we get string and number, because what this key of input does is it extracts all the types from the values in here. So it extracts here the string and the number, because this key of input is nothing else than a union of A and B. And we do exactly the same in here with our key of search in. We create this new mapped type, this new object, but then we use this key of and we extract all the values from it. And because of that, as you can see here, we don't get any complex objects in here. We only get the real types of our ID property. Now, the really cool thing about this approach is that we are not restricted to only one property name here. We can also add another one with a union. We can say or main ID. And we can see here when we scroll up here, we can see main ID here is of type Boolean. And when we now check here, we can see that we now also have the Boolean in there as an allowed type for an ID. So why does this work? Because in this key to look for extends key of, this can also of course be a union like we provided in here with this ID or main ID. So you are not restricted to only one property name in here, but as many as you'd like. And what we now can do of course is we can change this to ID, and let's remove this union again. And what we now have achieved is we have this dynamic ID type, which gets updated each time we change the type of an ID property. So in my opinion, this is a really cool way of keeping track of all the possible types a property is allowed to have. So thank you for watching the video. I hope you learned something useful today. If you did, please leave a like and subscribe to the channel to stay up to date for the newest TypeScript stuff. And also let me know in the comments what kind of topics you'd like to have covered in future videos. See you in the next one. Bye.